why GDG is a very interesting developer community.
I'm glad somebody has asked this question.
This is where the magic happens.
This is primarily a question and answer show. So if any of you out there would like to ask questions.
Welcome everybody. A really awesome event today. We're taking a behind-the-scenes look at Movi Kanti Revo, one of the new Chrome experiments that just launched yesterday. My name's Pete LePage. I'm a developer advocate with the Chrome team. And with me, we've got Aubrey and KC from Subatomic, who built this absolutely phenomenal experience. Do you guys want to introduce yourself?
Sure. My name's Aubrey Anderson. I'm the president of Subatomic.
My name is Casey Austin. I'm one of the lead developers on this project.
Awesome. So this launched yesterday. This is something that has been coming to fruition for us for probably 4 or 5 months now.
Yeah, about 5 months. I'd say we started storyboarding and concepting probably fully 5 months ago, and then did some initial concept work in the browser just to make sure that all our assumptions were or at least most of our assumptions were going to be true. And then we had a long period of just asset creation where we went out to Las Vegas and shot the Cirque people doing their performances on a big kind of blue cyc, and a lot of post-production and just getting what they call mats sorted out and getting everybody keyed, and and then and sort of in parallel to that, we have been Casey and I have been developing in the browser, working on building the scenes, and we'll kind of show you how we build the scenes as we go.
Cool. So for those of you who are watching live right now, we do have a moderator queue that if you want to go post your questions, you can go post your questions there. We'll take your live questions towards the end of our session. So as we dive into some of these things, please post your questions there. Cool. Let's jump in and talk about some of the 3D experiences and how those were built, because it's a pretty new concept for the browser to put all of these pieces into the world and actually build something that, as it rotates and moves, really has the perspective just changes. You've got really neat parallaxing going on, all of that kind of stuff.
Yeah, so maybe we'll show you a little bit in case you haven't seen the experience.
All right, well, if we can bring up the screen.
Laptop.
Great.
Looks like it's happening. So I'm just going to hold off on the microphone for now. What we've done, we've tried to keep to a sort of a theatrical approach, but do that with elements in the browser. And I'm just going to rotate this model as we look at it. These are all divs, which is a sort of important distinction from technologies like WebGL or other ways that you might manipulate content in 3D. But the other challenge we had is integrating video. So in this example, you'll see, obviously in the real experience, you can't turn the model around because that sort of blows it. But I think it's sort of good to understand how these things are stacked up in 3D space. We have the front layer here, which is a video element. That's a piece of WebM that we're loading and playing back. And that has the same background in the same proportions as you see when the interactive part of the experience starts. But if I flip it here, you'll see that's the back of the video. There's the C, which is actually tilted away from us a little bit. And then these other elements, the links and the back plate. And then if you can see even farther behind that is sort of the sky and the sea and some kind of foggy elements there. And as the video plays out, what it does is it just kind of cross-fades to the 3D elements behind it and creates this kind of relatively fluid experience. I think this is it's just about to do its crossfade here.
We actually built the scene in CSS with all the separate elements first, screenshot that, composited that screenshot into the background plate of the video, and then that got exported at WebM, so it crossfades perfectly.
Right. So there's a real back and forth, and for post-production people, this was kind of a new idea because they're used to just sort of getting a drawing, getting some art, and then having to put that into the video. But in this case, that was only the start.
Okay. So now, one of the things I know we were playing with and looking at early on was that WebM doesn't do alpha transparency yet.
It's true. That's fortunately for everybody. I think that's coming. And we worked with the animation codec as a way to kind of comp these things together, which does do video transparency. You obviously can't put that on the web because the files are hundreds of meg.
Yeah.
But one of the things we really look forward to is being able to actually live composite these elements right into the scene, so that rather than having a backplate inside the video like we saw and having to do these sort of hoop jumping of switching it out, we'll be able to just make the background transparent, key out the characters, and just park them right in the 3D model, which is just going to be insanely powerful.
And all the scenes are actually built now. Even the contortionist scene with the tree behind it, the tree was built with CSS, with every strip of bark on it is a different PNG.
Oh, wow.
So it's built in 3D and rotated behind the characters.
Okay.
And as soon as we found out that alpha wasn't going to make it in, we set it up to screenshot it, composite it again behind.
Okay.
But all the scenes are set up so they do work with if we had the alpha.
Now, so we have a case study that I sort of took this particular scene and took it apart and sort of built each of the pieces individually. But why don't we open up the DevTools and have a look at, or even some real code and have a look at what's going on here. Like, how is this built?
That's a super great idea. The other thing I just wanted to point out also is that you can kind of keep going in Z space. So here, if you hit the back button, we have the pink man, and this is just sort of non sequitur. It's just something that happens if you happen to find this.
So nice little Easter egg.
Easter egg, exactly. Right, you can zoom the whole model out, and you keep going in 3D space, both forward and back, and left and right, and up and down. Yeah, probably the easiest thing is to just sort of inspect some of this stuff as a way to get started.
We start with like the rotational containers.
Yeah, I wonder, I can kind of show you some of the anatomy of how this is built out. This is probably small text for you guys, sorry about that, but you will at least get a sense of how the rotation is accomplished. We have several div containers which have 3D perspective applied to them via CSS, and I think one of the biggest brain challenges is not thinking of elements as singular and transformable by themselves. A lot of times a complex transformation is happening because the element is moving and its container is moving on a different axis, and its container is moving maybe on a different axis. So we find this model is generally contained in 3 boxes, and each box generally handles one axis of the rotation, which gives us kind of an infinite flexibility in moving this model around. We can move it up and down, left and right, and kind of tilt it all around. But that requires 3 containers to really accomplish it in the way that you would want.
Okay.
I think I see it sort of when people first approach CSS and 3D, they're like, well, I have the element and I put it, I rotated it, and then I wanted to rotate it that way as well, and that didn't work. And it's like, well, you have to. It's a container within a container. It's just a slightly different way to think about it.
It's a lot easier to think about it that way. Is to separate out the translates and the rotates as well.
Oh, okay.
Because in the CSS transform, you have to have translate 3D and rotate within the same transform block in the same string.
Okay.
So if you break those out, you now can have the translate 3D on one div.
Right.
And then a container, and then another container have to rotate, and you can affect them separately, and don't have to worry about.
Okay.
So I just wanted to kind of point out a couple of things. We also lean very heavily on animation. So I'll show you this behavior real quick. So when this view first loads, you'll see it sort of does this long drift down here, and we're sort of drifting through this kind of 3D star field. Each of these stars is a PNG file that Casey has placed in real space, more or less.
There's one scene that just sort of blew me away. The one scene where the women are blowing the little fireflies off.
Oh yeah, totally.
And just the fact that each one of those stars is its own item that sort of moves in space and time.
Yeah, each one has a class. It's just one class for a star that has this tiny PNG, and I just loop through a couple hundred times, place them in random positions in Z, X, and Y, and then you can kind of, it gives you that parallaxing feel when you rotate everything.
Yeah, that's this view here.
Yeah.
This is an interesting view as well. Each of these elements is obviously, we're accomplishing transparency here, but not in the way you might think. This is a video that we're making manually by using a long animation and moving a background sprite around. So each of these women is actually a big sprite sheet of PNGs that we're applying an animation.
Oh, very.
And stepping from
very
scene
cool.
to scene.
Okay.
Since we moved through that scene, we can't do any sort of background compositing behind the videos, so we had to do, in this case, we had to do a sprite sheet, and it's basically like a insanely large PNG.
Wow, that's...
But I mean, even then, as an optimized PNG, it's like maybe 1.5 meg per sprite sheet. So
yeah,
like it's not that as big as a video would be, anyway. So
yeah, like I was gonna say, compare that to a video,
Yeah.
and it's pretty much
It's not too
it's
bad.
the
Not
same
that
size
bad.
or smaller in some cases.
Totally. But just if you're starting from scratch with this technology, I think it's just important to kind of understand how things get glued together. So you'll see in the code here, we're applying a transform on this element. This has an interesting side effect. When you translate something 3D, it also will bounce that element down into the hardware, essentially put it in the GPU's stack. Rather than having the CPU have to do it, and also importantly, think in terms of prefixes. This is probably how you will start working with it in Chrome. We use a framework called Neutrino, which helps us simplify some of the language and applies. Each of these has in a different browser context will have a different prefix, like that for Mozilla, like that for Opera. That for the various WebKits, Chrome, Safari, that type of thing. But we've done that. There's a couple of frameworks out there that'll help you with this.
That's awesome.
It's just nice. This is how it'll look in a year or two. So it's just good to get yourself thinking in terms of the unprefixed syntax sooner than later. And then and there's kind of a couple of things to try to parse through. There are transforms and there are animations, and animations are just sequences of CSS state. Generally, they're sequences of transform state, but it can be any state you want. You can go from a big fat border to a tiny border. You can go from a blue background to a red background.
Right.
And what the CSS animation engine does is it essentially tweens those states for you. So you express yourself in terms of where you want to start. I want the element to begin 700 pixels back in Z space. So these three elements, this is X, this is Y, and this is Z.
Yep.
And I would like it to end transformed 90 pixels over, that's 90 pixels to the right, 1400 pixels down, that is pushed down on the Y axis, and 100 pixels forward in Z space. So you can kind of think this through. The element is moving from somewhere back there to a little bit forward of, if you think of 0, that's the plane of your browser, sort of. But it's moving forward in space as well as down. It's also scaling, so actually a really immense amount of stuff. If you were thinking of this, trying to accomplish this in, say, a canvas, this would be very, very hard to express, just this simple thing. You'd have to get really granular about what was happening to the element frame by frame. But here we just say, start here and end here. Take 25 seconds to make that happen. And you can even apply some kind of easing, sort of Robert Penner style math to how you kind of begin and end the animation. In this case, ease in out means that it will sort of have a parabolic ramp up, get to a midpoint, and then have a parabolic ramp down, which just gives it a little more organic feel. And
we tried to use the animation as much as we could, like the bubbles. When you create a bubble, you just place it in a random position and then just add a class to it. And when you add that class, it adds the ascendant keyframe animation and the bubble rises. Okay. So you don't have to, go through. It's just as simple as creating the div
and
adding
that class, and
then it goes.
It's just all that happens
and
for
you. And if you create those at different times, then you get a bunch of bubbles all floating up.
Very cool. One of the things I noticed as I started playing with some of these 3D animations was that when you apply transform on the z-axis, it pushes it back, but it also does exactly what physics says it should do,
it
makes it smaller. So
true.
that's one of those ones where, you know, keeping in mind that scale factor is really important, because you're going to push something back or move it really close, all of a sudden it's going to go from being whatever size you expected it to be to being bigger or smaller.
I think that's another important thing to keep in mind too, is that what you get from the rendering engine generally reflects reality, but for an interactive environment, that's not always what you want to do. It's a little bit like deceleration physics on a touch device. They're not real physics, because real physics actually don't feel that good. Like if a real light, the way an element really decelerates in space, from an interactive perspective, is kind of not that cool. So same with transforms. A lot of times we'll find ourselves subtly scaling things up or down, and actually pulling them out of whatever you might characterize as realism in terms of a real 3D model, if you're thinking in terms of like WebGL terms. But in order to make them sit right compositionally, and just to make, when your brain looks at it, you go, oh yeah, that probably that tree and that person are in the same world. Oftentimes you have to bring the person way forward and scale them way down, because bringing them forward makes them big, and even though that is the right perspective, you have to scale them down in order to just buy it compositionally. Just show you another example of, these lanterns, you'll see they're sort of randomized, and they kind of float out, and then eventually will shoot up into the sky. Again, this is programmatically would be relatively difficult to express, because you'd have to sort of micromanage each of these elements. But in our case here, we don't actually have to do that at all. We have a lantern. This is how every lantern starts, and we have a little particle generator that makes a new lantern. Every time a lantern gets thrown up there, it's pushed a little bit in left space. It has some sort of width and height and all the stuff you'd normally do to a div to get it to render. And we set a starting point, and then we just attach an animation to it every time it gets added. And I think the attachment of the animation can happen also in JavaScript, which is important. You can sort of wait, and in this case, the lanterns start all hidden, and then JavaScript, when the video is ended, we get the ended event on the video, and we kick off these sort of lantern animations. So
the lanterns can start sort of floating in.
They can start floating in, exactly. But then we can forget about it, which is awesome. The lanterns all go through this same transformation, but JavaScript, as it loops through, is setting a different time on the animation. So the speed at which they go through it will change and randomize. The place they start, X and Y, will change and randomize. But what happens from there is always the same. It goes through this transform, it drifts basically up. But you know, if you think of it in 3D space, up sort of means away, because we're also scaling them down as they drift up. So you can see they go from this sort of Y positioning up to a slightly less Y positioning. And then in the last 10% of the animation, they shoot way up in Y, and which has the visual effect of making them go up into space.
Yeah, I think that's one of my favorite things about the animations, is being able to say, hey, this, I start at 0, I can, and obviously I'm going to specify my end animation, but you can also put in sort of middle points where you can say, hey, I want this to actually, I want the middle point to be maybe at 80%. You can get that math built yourself. Like you can go, oh, hey, I want it to go how I want it to work.
Absolutely, and you can get really sort of propeller heady about it. This, I believe, is 5-digit precision.
Oh wow!
Some browsers
I didn't know
have
that actually.
3-digit precision, so I recommend keeping it to 3. But I believe Chrome actually observes 5. But so you can get very, very specific. This in a 4-second animation obviously is not something you would do very often. But if you have a very long-lived animation, something that takes 100 seconds or 500 seconds. Sometimes to get the timing just right, like when you were motion mapping video.
That's what we were doing for the videos. I actually wrote something so when you hit the space bar during a video, it would put the time over the duration and log that, and then I could just copy paste that into here and do, and that's how we would track where things, to sync things up with the video.
Oh, that's cool. So you'd let the video roll and just
go video roll and be like, okay, I want that to happen here, and then boom, and then just copy that in, and that's where that's where that keyframe basically is.
Okay.
It's kind of like a cue point. In
It's Chrome as a tool for motion mapping. It's pretty badass. So do you want to talk about the Fireflies a little bit?
Yeah, so the Fireflies aren't, we couldn't actually do, I thought about how we could do it with that sort of keyframe animation, but we needed them more reactive. So they kind of, when they're made, they're generated, and then they sort of fly down the path in front of you in Z, and then when you get to the next scene at the fork, they kind of split and go left and right, and that's where you can choose a path or leave either left and right.
Okay.
And when you lean left, they have to all kind of hover to the left. When you lean right, they have to hover to the right. So in that case, since they're reactive, we couldn't really use the keyframe animations. So as you can see here, they're kind of just flying down in front of you. And this is, so there's a state that they all look for that's out in the main application that's called control. And if that's set to center, they just go in the center. If that's set to right, they all move to the right. If that's set to left. So you can call that from anywhere and set that variable. Like, for example, right now, if you...
So you'll see them, they're sort of more or less centered.
Yeah.
Or they're split, right?
Left and right. So if you go hit, just make this variable control. If you set it to right, you'll see them all kind of
and they all move to the right.
Over.
Totally.
Yeah, and then if you set it to split, they split, and then if you set it to left, they'll all meander over the other side. And this we had to do. These are there's an object. There's a few ways that I was experimenting with doing this. There was the jQuery thing where you can add data to a div, and that was the first thing, but I ended up just doing the way that I'm used to doing, which is I have an object that's a Firefly JavaScript object that has all the XYZ positions and the logic for updating it, the particle. So it's a very simple particle system that updates on every frame, and then I have a loop that goes through and updates all those, and then within that object there's also a reference to the div.
Are those guys their own view, or are they?
Yeah, they have their own view. It's Fireflies.js. So you'll see this is the Fireflies object. So this is the control here, so that can be center, split, and then disperse just sends them off of the screen. Where to generate them in the beginning is a whole nother thing to get into, but we needed them to actually show up at the end of the hand when the siren actually raises her hand. So what I had to do was find the X and Y position of that sprite sheet, and then go into the sprite sheet in Photoshop and see how many pixels left and top where the hand is.
Oh, wow.
And add that to the sprite sheet, X and
Y. So you were going, okay, here's my sprite sheet. I know that the hand ends at this.
And the hand pixel where I want it to form is there, and then you add that to the XYZ of the sprite sheet, and then that places it where you want it to go.
Right, at
and then you call that on WebKit animation iteration.
Okay.
So when that iteration is done, the sprite sheet is ended, that's when her hand is up.
Yeah.
Create the thing, and then it just goes by itself when it's, and you can see it in the update loop here. They let's see, this is all the variables for the setup, and then if it's left, it sets the center and border. If it's right, it sets the center and border. If it's split, it checks if its ID is even or odd, and if it's even, then it goes to one side. If it's odd, it goes to the other. And if it disperses, it just takes off the screen and doesn't mind the borders. It's a very simple particle system, but for this we had to update it on every frame with the interval.
Okay.
And then it's probably, do you want to look, let's look at the CSS as well, just to kind of see how they get bound together. Because the Fireflies themselves have
now they also have an animation on them, and the CSS animation is to make them blink.
So each of these elements, every time you add a div, you give it the class Firefly, it's going to obey these directions here and bind itself to the Firefly light animation. And it'll do this independently of whatever JavaScript is doing to the div that actually contains them. It'll just, this bit just keeps running on a loop.
And since they're created at different times, then they blink at different times. So
yeah, these will all go from 0. Animations are also interesting in the sense that when the element is visible, the animation runs, but they'll clean themselves up if you set the element to display none. The animation stops and unloads.
Oh, cool.
Which is, so we were sort of pleasantly surprised by how much kind of management you get with that. We never have to go in and cancel the animation.
Right. Like for the bubbles, for example, when we would create the bubble, it would play the animation, and then on WebKit end, we were setting display to none. That would clear the animation out of memory.
Right, and then it's not taking up memory.
Yeah.
You can
Totally.
something
It's
like
not
this.
on the render queue.
Yeah.
If every piece of bark on some of these things is its own element,
Oh, yeah.
It gets heavy.
You got to start thinking
Absolutely.
about a lot.
Or if you're
of
generating bubbles, every second,
Yep.
and there's the divs just start piling up.
Stacking
so
up.
on WebKit end, actually for the bubbles on WebKit end, I was actually removing the div.
Okay.
Yeah, oh right, when the
Yeah.
animation ends comes, you can just take the div out.
Yeah.
And there's an event that's fired when the animation
Yeah,
ends, right?
on
So you
WebKit
can
animation
go,
ends.
yeah, that event.
Both
fired.
transition and animation get a start and an end, and animations get a iteration.
Yeah.
which means that, like, if it's looping over a
Okay.
second, you'll get an iteration callback every second.
Okay.
You can actually fake a set timeout that way if you want to.
very
but
nice.
I didn't say that, and I don't recommend it.
Now, actually, that's a good point. I assume you guys used request animation frame as opposed to set timeout for.
We ended up using set timeout for almost everything, primarily for compatibility's sake.
Okay.
Because request animation frame, I think, is cooler and better, objectively speaking.
Absolutely, yeah.
But obviously this is a Chrome experiment, but we wanted to be as compatible as possible when you took it to another environment.
Yeah.
Not all environments speak
Right.
request animation frame, with some notable
Yeah.
notable exceptions. So, and then in testing also we did. I did a bunch of sort of parallel testing in terms of setting timeouts that way, setting them with animations, setting them with set timeouts. The main thing about set timeout is that you just have to be really careful that you don't leave anybody hanging. So when your view tears down,
clear
you just
them
have to
all.
make sure that anytime you set a timeout, you keep a reference to it, and as your view tears down, you cancel.
Yep.
I think timeout has gotten such a bad name for a number of reasons, but that's one of them. It's very easy to make terrible mistakes.
I think we would prefer to do the animation frame because
Yeah.
it is clocked exactly.
Absolutely.
Right.
But for this kind of stuff too, it's just fireflies flying around the screen. It's not, it doesn't have to be perfectly precise,
Right.
at exactly 60 frames a second or exactly whatever you need. So as long as they move around realistically, the interval works fine. As long as you clear it after, it's
Well, and for us, there's so much there's so much media happening. So a lot of times our timing, the holder of the master clock is actually a piece of video or a piece of music.
Okay.
So when we need, so if you look at the tree, for instance.
And just as a reminder, if people have questions, please go and post those on Google Moderator so that we can come back to some of these in a little bit. And as well, you can go visit this at movikantirevo.com. It's available as of last night.
Yeah, I heard it launched.
Woohoo! Yay!
So in this one, we have one big animation which is transforming the whole model, essentially creating a pan up effect. But we're not really panning up. Obviously, the one big div containing everything is actually animating down very slowly. And then there's all these sort of individual pieces of video that we're listening to specific events, the start, the end, and in some cases various timing events. So there's multiple things happening, but there's no set timeouts in this context. We're looking at how much time has elapsed in the animation and how much time has elapsed in a given piece of media, and those things are keeping time for us. The advantage there is, if for some reason somebody hits this on a slow network connection and the video takes an extra 5 seconds to start, obviously you don't want your timing to get all messed up. So you pretty much have to lean on the video to tell you, to kind of run the clock and tell you what's happening when.
We also have a simple cue point script in there that tracks the video on video update and tracks what time it is, and then you have an array that has times and when you want and functions that fire during those times. So as soon as it hits those times, it'll fire those functions off.
So like it's almost sort of
so you can bring up the video, see what time exactly you want that to fire. Like on the curtain when she leans, we need to trigger the curtain to open. So we'd say at 5 seconds, trigger the curtain left, and then it'll fire that.
One of the things I'd love to see happen in the media tags in general is some sort of a better way to plug into what's happening in the media world. Like a lot of times we have to manually set up a framework to observe a piece of media. The media tells us a lot when it's loading and about whether it can play or can't play. But once it's rolling, it's kind of quiet unless you ask it. Basically, you just go in and get time. You get the element and ask and ask it for current time. And current time will give you seconds and sometimes milliseconds. And then you have to kind of infer from what's going on. But it'd be great to have that API get deeper someday and be able to have the media tell us and create callbacks that we can listen for. But it's very new. It's very young. So there's a lot going on.
I think there's so many opportunities. We've got like the now with the web audio API. Hopefully we'll be able to get something potentially similar sort of for video that we'll be able to get a lot more stuff with.
And we had high hopes. Obviously we're using web audio and WebRTC in this, but one of the things we ran into, which I think just got fixed in Canary like yesterday, was the ability to essentially loop those things back and plug them into one another. Which you wouldn't think would be that big a deal, but it's actually super, super important when creating things like voice control. What we had hoped to accomplish here was to allow us to listen to the camera and the microphone, and obviously we're painting the camera frames in here with a canvas. But the audio, we cannot, or at least have not been able to sort of feed that back into the web audio API and analyze it. Our sort of dream for some of these sections was, she would come up and ask you to whistle, you would whistle, we would look at the frequency, use web audio to sort of analyze whether you had hit a certain frequency range and create different behaviors based on a low tone, a high tone, a loud sound, a quiet sound. And that's something that I think we will get to as we go. But it's really exciting to see that kind of come about, and I think we jumped on. There was a bug filed about it already, but we jumped on the bug and we're like, well, we're trying to do this and this and this, and then we saw other people kind of go, oh yeah, we want to do that too, and so I think it built some momentum and has now actually been sorted out.
So let's actually talk about the facial detection, get user media, and what's going on there, because you turn this, you start Movi Kanti Revo for the first time, and it says, hey, this application wants to use your webcam and microphone. Do you want to allow? And you click yes, and all of a sudden, there's your face. What's going on there?
There's a bunch of stuff going on there. The first thing that happens is when you click allow, it creates a video tag, and it sets the source of that video tag to whatever WebRTC gives you. WebRTC gives you this sort of string of gobbledygook, which is really just a kind of a reference, I think, so that the system can bind up to the feed coming in from the camera. But that's really only step one. The video tag doesn't get you very far in terms of doing motion tracking or anything like that. To do that, you really need to use Canvas, at least right now. So you never actually see the video that we bring in. The first thing you see is a canvas element. This canvas element has some sort of vignetting going on and some other treatments, which is why I'm sort of partially transparent here. But the sort of meat of what's happening is that the frames from the video are getting pulled into the canvas. We're then blowing through the pixel. The pixels of the canvas gives you a sort of big and unfortunately convoluted a pixel array. So it's actually just a big single list of pixels. And pixels 0, 1, 2, and 3 are the RGB and A of the first pixel, or those are the first 4 slots. So you have to take the slots of that array 4 by 4, and just make a note for yourself that every 4 means a pixel, and start your sort of pixel level analysis there and that way. And so we're using a couple of things. One is this really, really fantastic and reasonably fast JavaScript CCV library to recognize face. So the first thing we do is we do sort of it's very fast, but it's still JavaScript, so it's comparatively slow to like native code. So every second or so, we do face detection and average out the things like the size and the location of your face.
Okay.
And so if you kind of lean in, it's keyed to zoom, and that will sort of trigger the zoom in. Leaning out will sort of push out again with the zoom level. And then from there, we're just looking at what I think of as pretty traditional motion detection. We're and Jason, who's not here, wrote this, and he's very smart. It blows through the pixels. It looks at an interval. It looks at what that pixel looked like last time it checked and what it looks like now, and sets a threshold for a difference.
Okay.
So if that pixel is different enough, that is the color or the tone has changed past a certain threshold, we call that motion. So that means there's something happened. There's some places where that falls down, but actually in practice, especially if the laptop or whatever is sitting on a table, it's pretty darn accurate and actually very, very fast. Fast enough where this is probably 15 or 18 frames per second. And we're still doing all this other stuff in 3D transforms and animations and stuff. So it's we're definitely beating up the JavaScript runtime pretty badly, but it's okay. It actually runs.
We're pushing the browser.
And we threw all everything else onto the GPU with the Translate 3D. So that frees up all the CPU that we can do this other stuff.
Yeah, it's that sort of balance. Anything that you can say here, graphics card, and get it out of.
You go do this.
Yeah, I mean, this is a huge difference. This is sort of a tangent, but like the way we used to do it with JavaScript, or like if you do jQuery.animate, or anything that is essentially clock-based animation, where JavaScript is setting timeouts or running an interval and observing elements. It's just dog slow compared to, and even with a very fast JavaScript runtime, it's that sort of single-threaded, like JavaScript has to think about every frame, which, I think there's 150 lanterns, there's, this background animation happening, there are, all these elements positioned in 3D space, the canvas analysis, the video coming in, there's a lot going on, even in this one page.
So I think one of the things that just sort of blew me away with the Get User Media and WebRTC is like you get access to the camera, of course, user's permission first.
Yeah.
You then take that, render that onto canvas. You can do whatever you want with it from there. It's not going anywhere. It's all that video is sitting on your local machine, right? So you're doing all that analysis there, and then being able to make an entire scene and world move about in that way. So as your head goes one way, you start to tilt the world. To go back to the 3D transforms we were talking about earlier, you start applying those. Yeah,
we have, in the real app, we have thresholds on these 3D transforms. I've turned them off for the sake of this demo so you can see and spin the whole model all the way around.
Is that something developers can go do very easily? Is there a place in their DevTools they can go?
There was one variable, author mode, that turned it on, but since you'd have to just take one condition out.
Okay.
But yeah, it's just one condition.
It's tweakable. Maybe I'll send it to you and you can post it somewhere.
All right, yeah. That would be kind of cool. Like, because it really is one of those fun things for developers to go, oh, hey, like, I want to take this apart. I want to see what's going on behind each of these pieces.
Well, and you can also, you don't even have to do that by tweaking variables. You can actually go into the inspector and just change the
that's a good
Translate 3D state of the element, and you have, almost all the elements here are transformed in 3D space, and so you can just go in and change the rotate Y value, or add a rotate Y value if it doesn't have one, and you'll see it do this.
You got a force perspective container and go into the XYZ of that. And
you can just sort of
whatever you want.
Move it around.
See how that happens.
I like that you get to see the back of the video too. You don't have to have this, but we've left it on just because it's kind of cool.
Well, and that was one of the things, I don't think we ended up doing it, but I remember us talking about it at one point, was like an Easter egg where like if you actually turned the scene around all the way, you actually would see sort of the back, like almost backstage kind of thing.
Yeah, totally. There's we had kind of a long list of extra wonderful things that time is always against you when trying to actually ship something. But yeah, there are several little things if you dig around. I don't wanna give them all away. But.
Cool. And yeah, we definitely don't want that. I think we've given one good one.
Yeah, there's at least one good one we gave away.
Cool. So one of the other things that we thought about with this experiment was mobile experiences, right?
Yeah.
Do you want to talk a little bit about how you approach that?
Yeah, I guess there's another sort of important side effect to letting CSS do a lot of this heavy lifting for you. One is obviously it's just easier on the JavaScript runtime.
Yep.
But the other kind of cool thing is that it's very portable. So any other browser runtime that thinks about things this way will allow you to render these elements on the GPU of whatever device you happen to be looking at. And so we're kind of fortunate to be coming into an era where a lot of browsers speak the same, or at least subtle variants of the same language.
Pretty close, yeah.
And we'll do the same things with those instructions, particularly animations and transforms. So as we set something like transform translate 3D, we now have support for this in pretty much all major, at least the latest releases of all major browsers, and mobile.
Yeah.
So mobile, and in the mobile space, it is particularly important because obviously your CPU is pegged down quite a bit. You're generally running on it's sometimes dual core now, but it's still 100 megahertz, and it's a phone. It's also doing whatever the phone needs to do, and there's a lot going on. It's not just the browser. And so the ability to take elements in the browser and render them on the graphics hardware is really, really huge and really important. And if you look at this experience on tablets, you actually get pretty competent rendering, and in some cases really kick-ass rendering, just by virtue of this same thing. And places where we don't have a really good JavaScript runtime, we can dodge that to some extent by rendering right on the hardware.
Yep. Now, we don't have Get User Media on mobile, so instead, did something I thought was brilliant, and it makes perfect sense.
Yeah, what we did on mobile is we pegged that behavior to tilt. So as you tilt, you'll see this kind of interface here, which is like a little sort of four-way controller. This is a poor man's D-pad. And as you tilt, you will get the sort of same effect as if we detected motion on the left and right side.
So tilt device orientation, so that as you tilt the device, it gets that same thing. And it's pretty rare that I'm going to pick up my laptop or desktop and go, "Oh, look, I can do this." I've done it a few times for a quick little demo, and it's kind of fun, but you're not going to give your kid your laptop and say, "Hey, go play with Movi Kanti Revo and tilt it."
Yeah, totally.
So it doesn't work there, but it works so beautifully on mobile where people just naturally think, "Oh, well, ooh, cool."
Yeah, we tried to, on the mobile side, do the thing that you would think it would do to the greatest extent that we could. So wherever possible, we just tried to do the right thing, and the thing that you might expect as you.
We have sort of this higher level thing that makes it lean either way, and then now accept input from wherever you want. So if it's the widget that has the video stuff, that'll tell it, or the tilt, or whatever else we wanted.
Cool.
Yeah, you can really map any input into the general rotation controller, and wire up whatever type of control you want. So you could easily wire it to touch
keyboard
move or keyboard.
So we could even like gamepad controllers.
Yeah, you could do gamepad controllers.
HTML5's got the API for doing that. So like you could.
Yeah, you could drive the whole thing. Yeah, there's some potential there.
That would be really fun.
Yeah,
that would be really neat to go do. We've been playing with one for our Chrome apps. We've got one of the Parrot drone helicopters, and we managed to make it fly using purely HTML and JavaScript.
That's great.
With a Chrome app, which
fun.
Awesome, like tons of fun to go do.
Yeah, that's really cool.
I'm going to start pulling up some of the questions to see if people have, if they've submitted stuff in that. But what was your favorite part of this project?
I don't know. Do you have a favorite part?
Just overall, probably just getting to the point where I can be creative without having to think about the CSS and all the code and everything. You know what I mean? Getting to a point where I can set things up, get things moving around, build these scenes out without thinking about the code anymore. I think that's the best thing when you finally get to the point where you're not thinking about how things should be set up. Because we went through so many iterations of do we do CSS animations? Do we do JavaScript? How do we set the things? How do we have the scenes set up in 3D? Once you get to the point where all that kind of workflow is all settled, and then you can take the assets from the beginning, build something at the end. I think that's the best part.
Totally. I really liked also when we were shooting in Las Vegas, we had a lot of these models, or at least preliminary versions of the models built. And so we were able to take really quick keys from the camera and just make quick movie files, and they were sort of rezzed out and stuff, but we were able to drop those right into the environment as we had them mocked up, and show the actors, show the performers what they were going to look like in the environment. And then they were like, okay, I see, so I'm in a forest. And I think it, when they went back and did another take after seeing it, I think it changed their idea, and it gave them a real sense of what was happening, and I think it changed the quality of the performance, because they could actually pre-visualize.
They were in in this blue screen room, like literally it was this cube of just pure blue.
Totally.
And you can't, it's hard to imagine in that without having something to start with where you're going.
And mocking the scenes up and just having layers is really fast. So you can just have that set up, throw them in, show them how it looks, even change stuff on the fly.
Yeah, move things up and down in Z-space, scale things around, and that's all, because it's all CSS, and you're not down there and making a code level change and forgetting a semicolon or whatever. It's very, very quick and easy to change. You can change it right in the inspector. It was, I would say, my first experience with something that was that real time with that kind of media production.
And to see them all come over and look at this and go, like, they were just so amazed. And in fact, some of the artists were at the launch last night. They hadn't, like, we've been heads down in this. We've seen this
they'd never seen
hours and hours and hours a day, and they had never seen it. And the look of sort of joy and glee and excitement on their face to see them in this world was pretty phenomenal.
Right on. I had to talk, I missed that, but I'm glad that happened.
So a couple questions from the audience, and please post any more as we're going through these. But first question was, somebody tried to run it in some of the older browsers, so like Firefox 3.6 and IE9, and it doesn't degrade gracefully, and besides WebRTC not working, why didn't it work in those older browsers?
The big barrier is the ability to translate elements in 3D space. So, and that is, it's sort of early on we were like, well, if we do it this way, we are going to lose some of the older browser renderers. But, this being a Chrome experiment, we wanted to really show the latest, greatest, and do the really best we could do with the technology that we have on the sort of bleeding edge. And not that WebKit Transform is particularly new, but support for it, broad support, is pretty new. So the big barrier for older browsers is that they will not translate elements in 3D space.
So
a lot of them have translate Y, they have translate X, or they have a translate function that takes an X and a Y, but there's no Z. They also don't do that work largely on the GPU. So the barrier for us was a browser runtime that when you ask it to put an element, position it in 3D space, it would do that for you and do the right thing, and hopefully do it on the graphics hardware wherever possible. So you'll see this on Windows XP as well, like Chrome ships with acceleration turned off by default on Windows XP. And so even though Chrome can do it, they, I think, can't reliably be certain of the GPU environment, so they hedge the bet and ship it off. You can go into about flags and turn it back on. But yeah, the browser that can't speak that language, we had to just let those ones go.
Or even just like having you can have the newest version of Chrome, but with a super old GPU, it just won't know what to do with those layers.
Totally.
Yeah, and one of the really important things about Chrome experiments is they are meant to push the web forward and show what's possible on the web. And that's sort of one of those things where, this works in almost all of the modern browsers without any craziness going on. And so we want to push that. We want people to look at this and go, holy smokes, this is all HTML. I can do this myself. I can go in and look at this. There's nothing proprietary in here. There's you can view source on the code on this.
Yeah, you changed the whole thing.
Yeah.
Well, and I think it's also important to really understand that this is an art piece. We're not trying to sell refrigerators from this website. We're trying to do creative work with new tools that we have discovered in modern browsers, and that's. I think the experiment part of the Chrome experiment is. We're fundamentally pretty creative people, and that's where our kind of hearts and minds are. We're also technical, but the point of this whole process was to take the tools that we have discovered in the browser, push them as hard as we could in the name of doing something artistic and creative.
Cool, awesome. Well, so the next question, was it easier to do this in HTML and JavaScript than it was in Flash?
Oh, that's interesting.
And we talked last night. You came from a Flash world.
Yeah, I'm in the Flash world since '98. I helped, shape the plugin. I've been working on it, for years and years and years. And it's not so much a matter of could we do it better in Flash, or Flash has all kinds of different effects and filters and everything, bitmap level stuff, and you do get the webcam across all the browsers, which would be great, but it's more the point of being challenging and doing it without Flash.
Yeah.
You know what I mean? Because
Yep.
and this is the future, so I think it's we have to push it, and eventually we will have everything that we have in Flash.
Yeah.
We already have the CSS filters now. Mm-hmm. With Canvas we're getting bitmap level effects, so it's it's getting there, and we just need to push it forward until it is 100%.
Yeah, yeah, and I think this is something that we will absolutely get to, and this is something that should, I think, in many ways, much more accessible to people.
Yeah, and
right?
if you say we could have had the microphone in Flash, and we actually thought about having just one element just to grab the microphone and pipe it in just from Flash, but we decided against it just because we wanted it to be a complete HTML5 experience. And now, yesterday, we do have audio in Canary, so it's that, and because of the fact that we're pushing it forward, so the next thing that we do, we will have that.
Yeah.
I also think it's really important that this is markup. We're doing things declaratively by and large in this application, which is fundamentally a different idea. So
it took me it was a paradigm shift for me to work in this. I have a very game programming mentality in Flash, and I have the way that I set things up is completely different, and Aubrey had to kind of turn everything on its head for me to go to get to actually.
So you had to apply that 3D transform.
To your brain.
And then rotate.
Exactly. So I had to change things around completely and get back into that markup, CSS, JavaScript kind of mentality. And
Cool. So the next question: what kind of DOM and JS cleanup did you do to keep the performance and memory leaks to a minimum, as the user stays in this experience for it runs 10
has to clean up
minutes.
everything. You have to clean up all the intervals. You have to, and then the neutrino with getting things off the setting display to none after the pages are done.
Yeah, we're working within a framework that we also invented called Neutrino, and what that does is just gives you sort of a simple life cycle, also some lifestyle management, but mostly life cycle management.
That would be a pretty phenomenal framework to have.
It comes with a hat and some cool sunglasses.
Awesome! Sign me up.
It's a tool that allows you to think in terms of kind of atomic modular views, and the views have a life cycle. They become visible, they become invisible, and it just helps you manage some of that stuff. our friend in this situation is display none. So what we found in browsers is display none takes it out of the memory stack.
Okay.
And so then you just have to be careful about what JavaScript is doing. Make sure that JavaScript is not running away, or you don't have an interval or a timeout still running. But by and large, if you are animating with webkit animation or with transforms, and you set display none on any block of HTML, from there all the way down the stack in the DOM is just yanked, and it's yanked actually fairly quickly.
Oh, awesome! Okay.
And you get the memory back almost immediately.
Okay.
So obviously each of these scenes has hundreds and hundreds of things going on. They're massive. They're transparent PNG files. They're video files, and all those things. And so setting display none to a whole block, we can actually leave it in the DOM. Though in some cases we do, some cases we don't. But
I was doing some cleanup where on WebKit end I would actually remove the HTML element, but that was more just for me, just so there wasn't 2,000 divs in the DOM. But
yeah, totally. The one exception I think is video. Obviously, you even display none on video. It's a little squirrely, so you'll see if you watch the life cycle in the DOM happen, just let the thing play. You'll see videos, kind of video tags getting injected. They'll play, they'll get pulled. So we do try to do some more aggressive cleanup and management on video and audio in particular. But for animations and all that stuff, it's just kind of wonderfully managed by virtue of the view state.
Cool. Cool. All right, well, so we've only got like a couple minutes left. I'm going to take this last question. I think it's a wonderful question, but how would you recommend a web developer that didn't do any animations start using them in their next step? Is there a good framework or library that they should look at, or is there a set of tools? How do they get started?
I think HTML5 Rocks is actually a pretty nice place to start. I'm not just plugging a Google thing. Like, it actually is a nice place to step through an approach to that.
That's what I was going through a lot when I first started, was just go through every one of those things and just get things moving around on screen, very simple things, and just build, kind of snowball up your toolbox of different, and go through each of the functions, check out all the different timing functions, durations, all that kind of stuff.
Yeah, and it's you do need to just kind of jump into it, make an animation, and watch it go. But given the it's not actually that complicated. So in some ways, it's something that is knowable and easy to experiment with, and you can just do it in HTML in a browser. Just inline your CSS and mess around with stuff. And I'd start very simple. Just make yourself a keyframe sequence with a 0 and 100%, and just apply it and start.
See what happens.
Yeah, you'll sort of feel your way through it. It's like any new technology where there's a confused couple of hours. But it is actually really well documented and increasingly well documented. The first couple of years, it was really, really hard to find anything. But I found, this year in particular, a huge ramp up in examples and copy paste your way through to something happening, and then just start tweaking things, changing variables, changing time, and note, and you'll go, oh, this is a good way to do things. It takes a minute to just change your brain around from thinking of there's a thing, I'm going to select the thing, and it's going to happen. Largely we key animations to class states, so you're still selecting things sometimes in the runtime, but it's a lot of times you're just doing document.querySelector something, and you're adding a class to it or subtracting a class to it.
Cool. All right, well, I want to thank you guys so much. We do have a case study about the building the 3D world that's up. We've got a bunch of other case studies that we're planning to put up over the next couple of weeks, because there's just so much behind this whole experiment, this whole world that is just like, wow.
It sort of
really
leaks out of
deep.
my ears.
Thank you guys for joining us.
Thanks for having us.
It's been really great to have you and sort of dive in behind the divs here and have a look at this. Thank you guys for joining us, and go check out Movi Kanti Revo. It's at Movi Kanti, Kanti Revo. URL's on screen. Have a wonderful day, everyone. Thanks for joining us. Bye-bye.